Great. Thank you very much for the invitation. Thank you very much for everyone coming along. I look forward to hearing your questions or your comments. So what I'm going to focus on is what I know best, at least of late, which is the pre-university qualifications that students, regardless of whether they're studying mathematics or another subject requiring a quantitative element. It's primarily focused on what I know about in England, but there's quite a lot of commonality, at least in terms of the global content in the other devolved nations. So in terms of delivering on all this, we are relying on students having studied, well, for many disciplines, A-level maths and further maths in England, and similarly in Wales and Northern Ireland, and then hires and advanced hires in Scotland. In England, we have something called core maths, which there's something similar to that in Scotland, and there are thoughts about having something similar in Wales and Northern Ireland, but that hasn't yet transpired. And then also GCSE mathematics or equivalent at level 2. So I'm going to talk about the past, present, and the future, how we've got to where we are and where we might want to go in the future in this regard. So I put a few questions, if you saw them on the Talmo site, about the things that I often think about and many others think about as well, which is we've had some reforms, different reforms in different devolved nations, but in a similar vein. Have they achieved what we wanted them to achieve? Are they achieving what we want them to achieve now? And will they achieve what we want them to achieve in the future? And my guess is that the answer to the latter question is no. So we need to think about how we might reform, evolve. We hopefully won't need a revolution. So there will be many slides, and I will talk very quickly, but you'll have the opportunity to look at these at your leisure. And I'd also offered John and Hariko the opportunity to have a separate session where we can flesh out more of this. But I've captured here many of the words that were being bandied around when in England we were talking about maths to 18 in the last couple of years before we had a change of government. So I've put there the importance of teaching, and we all know that there's the intended curriculum, there's the enacted curriculum, and then also what's assessed, and they're not always the same thing. And what we know is that what typically the product of the school system will depend on the way the students have been taught, and then how much they've engaged and how they've learned. My involvement has been in the stage prior to that in terms of what is the intended curriculum, but we all know that it's actually the assessed curriculum, the assessment, which drives teaching and learning. I've put there a phrase about the importance of A-levels to universities. Actually, that's plagiarized from the 2010 paper in England, The Importance of Mathematics Teaching, or Importance of Teaching, but particularly relevant for mathematics, which ended up giving rise to the reforms for A-level mathematics first implemented in 2017 in England. So we there tried to construct not just content, but a way of how mathematics should be taught. And I'll talk about how successful that may have been and how we can learn lessons for the future later on. But there are essentially three overarching themes for the A-levels in maths and further maths in England. But there were two, if you like, subparts to that: the use of technology, increasing use of technology we'd hope to see in the teaching and learning of mathematics, but in particular in statistics and the use of technology in the teaching of statistics, particularly through the use of data, which is often what statistics is there for. So we introduced what's called the large data sets, and this went down like a lead balloon in some parts. It's still a really important thing that we need to pay attention to as we move forward in an ever increasing important area. How we enable much greater study of statistics through the use of data is yet to be realised in its fullest form. I think the outcome from the 2017 reforms were positive, at least they were, until maybe we've seen the throughput, and we've also had additional challenges with COVID. But hopefully there are lessons to be learned through that. I certainly feel that what we had prior to that was not fit for purpose, not completely fit for purpose anyway. So the overarching themes, you can look in the subject content. I can share the links in the slides. But this was, in a very short period of time, I could like to consider well thought through, because a lot of people have been thinking about reforming A-levels for some while. The emphasis on the use of technology and the use of data in statistics was a particular feature of the content. It then is a more challenging aspect to translate what is a content document into a qualifications and assessment framework, because these are done by different bodies. But we do have, in addition to the overarching themes, how we believe that the content should be taught, a series of, and as you can see, quite a large number of items with quite a lot of detail. Prior to 2017, there wasn't a lot of detail in what was the core curriculum. We tried to put that in. And one thing we were particularly keen on was what we call mathematical problem solving. And this was our definition of mathematical problem solving. And we would like to see unstructured questions as well as structured questions. You have to have both. In particular, in England, you've got an A-level in mathematics that's just had over 100,000 entries, and it's serving many different needs. So getting the assessment right is challenging, but in particular, students that are going on to mathematics degrees, it's even more challenging because they're only a 10% or less of that sample. What I've put together here, because this might interest you more, not necessarily for now, but you can reflect on, I've put together a series of questions from what I call legacy papers. So 2019 was the last year in which students sat A-level mathematics in the pre-reformed system. And there students were doing modular A-levels, but typically to get an A-level, you had 6 units, which were assessed, might have been assessed in the whole of year 13, but typically half in year 12 and half in year 13. But it comprised 9 hours of assessment. What we've ended up having is what is meant to be the equivalent challenge, but only in 6 hours of assessment through 3 2-hour papers. And I focused here on calculus. And I leave you to see whether you believe there are any differences in the emphasis and the challenge in the old specifications as evidenced by the assessments, and the two are different. What's meant to be taught and how it's meant to be taught, and then how it's assessed, are different things. But there are, for me, some striking challenges, but in particular the amount of assessment in the area of calculus for what is broadly meant to be the same topic. If you've got 2/3 of the amount of assessment, you can't ask as much. And I don't think you can necessarily draw out, particularly at the higher end, students' abilities. Anyway, these are the questions in the last set of 29 legacy specifications for one of the awarding organisations. So there are quite a few interesting challenges, and although there are some structure here, they tend to be reasonably lengthy questions. So you can't just jump from one question to another. And I think they're a pretty decent challenge. The issues that we had with the pre-reform qualifications, I don't think you could evidence from these assessments. And so there are quite a lot of calculus questions. Now, of course, students can do calculus just using technology, but I think it's important to have a fundamental understanding, even at A-level, before you start university. And for me, that's something that has changed over time. It's something I still look at, how much calculus and how are you assessing it? Because you can assess a lot of problem solving skills in calculus as well. So there are all those questions, quite a lot. Moving on to the reform, it's the same specification, but now the reforms, and we've got less assessment for this. And for me, there's an element of more structure, much shorter questions in total. And you'll see there an example of, proof of the derivative of sine. Actually, that was never what was intended to be something that was assessed, but and that causes some analyst horror that it's taught at A-level anyway. So this is the group of questions I put together, and they're all, as I say, from one single sitting of a reformed qualification. And then move on to specification. This is another specification. It's been accredited in the same way. It's assessing the same content and meant to meet the same overall standard. This particular specification, it has a number of multiple choice questions, which can be good, but also can be more challenging. They're also much shorter questions, except we move to this, so it's a complete change from the nature of those questions to one which is still structured, but a little bit more demanding and more information to assimilate. And that was it. So you'll see that on that second specification, in my view, much less assessment for calculus. Whether the overall level of demand is the same is for you to decide. And there are 4 specifications. I'm only showing 3, but this is the third specification. And again, some structure, slightly more short answer questions, slightly more perhaps leading the witness. Actually, that was not what was intended. But this was my remark about what was intended and what was then delivered. And what's delivered is then often hugely informed by what is assessed and how it's assessed. So again, there was some reasonable questions. And then I want to move on to, and that's the hardest question on the set of papers. Now, admittedly, in the pre-reform qualifications, what typically happens is a student would end up getting an A, and the bulk of their marks were on, say, the 2 pure modules, the more basic pure modules, the AS modules and the application. So actually some students didn't do terribly well on the final core 1, core 3 and core 4 papers anyway. Now this is a question, well, actually this has appeared on an exam paper, but not for some while. And in fact, this is not all of it. I would like to see slightly less structure, even if it's only in the last 1 or 2 questions. This is a particular specification in the past where they like to ask questions with using parametric integration. There was a little bit more structure to this question, but I see no harm in asking a question like this for the more able students who are getting A stars, in which there's the information to assimilate, and at the end it says find the total area of the red glass. Well, the red glass happens to be the bit which is outside the shaded read in all 4 quadrants. Once you get stuck into it, so long as the students have sufficient time in the assessment, it's manageable. Now, I'll put a link in the chat to a paper I'd published about grade outcomes across the different specifications back in 2024 in MSOR Connections. I've updated one of the slides for that, which is the following. And what you see here, I've only put on grades A star, A and B. And I've made, for example, on the left, a comparison between the grade boundaries for specification 1. And you'll see there's been a shift. Now, the shift might be because teachers have got used to what the specification is required and how to teach to that, or maybe it's another reason. But you'll also see, if you look at the 4th, the 5th and the 6th bars on the A star, the same specification from 2019 to 2024, not a huge shift upwards, but you notice it is much lower in terms of the grade boundaries. Now, anyone coming up with their own explanations as to why this is the case. I still think it's slightly concerning that you've got an A star having to be awarded at, getting on for 90, the yellow one, compared with something much lower. That's due to the nature of the assessment. The question is, what's right? So we all rely on students acquiring either basic or advanced knowledge, skills in mathematics, and I'll put more generally for all students who we teaching through, whether it's through service courses or those of you who work in other disciplines anyway, biologists and so on, rely on what students have acquired. But the question is, what do we mean by mathematical and quantitative skills? I put a huge list up earlier. What's important is that it's the right ones for the course that the students are going to go on to. Now, a piece of work that the Royal Society have been doing, the Mathematical Futures programme, and there's a mathematical data education report that was published in the autumn that I can highly recommend, is a visionary piece of work thinking about reforming the whole of maths education up to the age of, pre-university. And it thinks about, in particular, something like general quantitative literacy. Now, I would argue that for many students, general quantitative literacy is important. It's certainly important for all of those students at university who are not doing a mathematics course, but have a quantitative element in their degree. I'd also argue it's quite important for those doing a math degree as well. And it's also important for further study beyond university and life and work. That currently doesn't appear in the GCSE in mathematics in England. I think it does in the applications of maths in the nationals in Scotland. So there's something there to be celebrated there, but more needs to be done. And it also, the Royal Society also talks about, because we don't have a competency-based assessment, we have a normative-based assessment. Students can be doing well on GCSE, not at the top, but well, and you're receiving them for other disciplines other than mathematics. And it turns out that there's a large swathes that they don't understand. Well, that's not very helpful, but I'm afraid that's the nature of the way we currently offer qualifications and how they're assessed. And in particular, if we just look at the grade boundaries for one of the specifications last summer in England for GCSE, grades 4 to 9 are a pass. Typically, students are required to get 7, 8, and 9, but sometimes 6 is sufficient to do an A-level in maths. 4 and 5 are passes, and many students are going on to university with grades 4 and 5 in GCSE. And the percentages that they've had to achieve in what's the higher tier at the lower end are quite derisory. And so it's no wonder that students come and it looks like there's very little they can do. So lastly, I'm going to talk about something quite passionate about everything I've talked about so far, but something called core maths. So back in 2011, the Royal Society and many others did a piece of work on the mathematics, the nature of the study of mathematics for students who are not doing A-level maths, but who are giving up GCSE maths, but nevertheless are going to university and into work and for other study who require mathematics study, quantitative study, which they weren't having the opportunity to do. So core maths was introduced for that purpose, and there are 3 broad aims for core maths listed there. And there's content in there, but it's more a question of how it's taught, the nature of the problem solving, and in particular how it's assessed. And how it's assessed tells you quite a lot. So I'm going to just go on to some of the assessments, but for those of you that have heard me talk about core maths in the past, we did have a bit of a win earlier on in the year, so that from 2024 intake, every student taking core maths attracts an additional to their standard post-16 funding, £900, which is, in my view, quite ample to teach a class of 10 students a couple of hours a week for a year. So you can again look at these questions at leisure. There's some structure to them, but they are typical of core maths questions. We're asking something quite different to what we ask in A-level mathematics. I also think it would be quite useful for students who are doing A-level mathematics to have this kind of challenge, but this is absolutely something that is not done at GCSE, and so many students who would benefit from this challenge are not having it. We've only got about 13,000 students doing core maths, and we should have at least 200,000. And some more questions, which again you can look at your leisure and try even. So 3 other things I want to mention in brief. One is the bond review that's in the end given rise to the Academy for Mathematical Sciences, who have a real interest in the future curriculum across the whole of the UK. And if you read this extract from the bond review, it talks, as we all know, about the importance of continued mathematics study and research in an ever greater area of disciplines. And that's why it's most important that we get our curriculum, teaching and assessment right in pre-18 education. The Royal Society also had a report on dynamics of data science skills, and data science is everywhere, as we all know, and there's a huge amount of emphasis in the Royal Society's mathematical and data education report, but this has also resulted in quite a lot of activity, at least in the professional area. And finally, the Royal Society report, I commend this to you most highly. A lot of work, a lot of time, a lot of experts over about 4 years has been put into this report, and it is a vision for the future, and it talks about how it could be delivered. So this is what Adrian Smith said around the early days of the work. He always cites core maths. He's my everlasting friend for that. And there are some series of highlights in the report that I've put here. They're all absolutely obvious when you look at them. But I'm going to finish with what it says here. They've got a number of recommendations. One of their recommendations is to design and implement a curriculum that integrates appropriate data, statistics, and computational tools coherently with the mathematics. I think that would serve much better all of the students that we currently teach and support, whether it's in school and when they get to university. We don't have that at present. We have, in some senses, quite a narrow GCSE curriculum in England. It speaks to the higher attainers, and then many students stop doing maths post-16. The ones that do A-level maths possibly could be slightly better served than they are, but we are still missing a trick. So there are 3 aspects to the Royal Society's work. It talks about foundational advanced mathematics, which is very much building on much of what we already currently do, but thinking about the future. And we all have a vested interest in this, so any opportunity you have to get involved, please do. General quantitative literacy, which is fundamental to much study in other disciplines other than mathematics in all our universities, but I fear is not widely covered, except maybe for applications of maths in Scotland and in England through core maths. And domain-specific competencies, this is about maths in context in the discipline that you're studying. And then finally, the DfE in England, Department for Education, is doing its own curriculum assessment review, a very short window to put in evidence, and they need to report, I think, by next autumn. I don't think the outcomes of this will be massive scale change, but if the areas that need attention are not attended to and they don't pay attention to the Royal Society's work, then we could be another 10 years down the line still doing the same thing we're doing now, and I don't think that would be right. Anyway, thank you very much for your time. Sorry I've gone over. I'll stop sharing.